Welcome to this live session. Okay, let me give first a brief overview of what we have done in this course till now. So in the week 1, we have learned how to derive the demand curve of any good of an individual, and from that individual demand curve we have moved to the market demand, and we require the market demand of any good. So based on that market demand, firms are going to decide how much to produce. So in the first week we have derived the market demand from the individual demand, and that we have done based on utility maximization subject to a budget constraint. Then what we have done in the week 2? In week 2 we have first derived what is the optimal mix of input that a firm is going to employ to produce a given amount of output. So for that we have solved a cost minimization problem. So it is something like this, that a firm wants to produce some given amount of output based on a production function, and it wants to minimize the cost. And we have done it in the most simplest case, and that is where we have taken 2 input, that is labor and capital. And from that cost minimum input bundle, labor and capital, we have derived something called the cost function. Now, what we have got? We have got the market demand, and suppose a firm wants to produce that amount of output, some fraction of that market demand or the whole of the market demand at a given price, then what is the cost it is going to incur? We know that. So these 2 things we have done in week 1 and week 2. Then we have started looking at market. In week 3, we have looked at perfectly competitive market. So it is the benchmark model for any kind of competition, because here all the firms take the price as given and decides their only optimal output. They cannot determine the market price. So the market price is determined based on the interaction, or you can say it is the intersection point of the market demand and the market supply. We have derived the market supply from the supply function of each firm. Supply function of each firm is actually that portion of the marginal cost firm, marginal cost curve, which is above the minimum of average variable cost, or average variable cost, simply average variable cost. So we have got the market supply and we know the market demand, and wherever these 2 intersects, or it is the price at which quantity demanded is equal to quantity supplied. So that price is the equilibrium. So we have got that price, and that price is taken as given by each firm, and they decide the optimal output. So this was done for the short run. So there may be profit, there may be normal profit where the profit is 0, or supernormal profit where profit is positive, or there can be loss. That is, profit is negative. But in the long run, a firm is not going to stay in the market if it is making continuously losses. So in the long run, what happens? There can be entry and exit of firms in this setup. And so, what do we get? That if there are supernormal profit, the prices are going to supernormal profit, then the firms are going to enter this market. And once firms start entering the market, what is going to happen? The market supply is going to go up. So the supply curve is going to shift rightward. And so the price in the market or the equilibrium price is going to go down. So then what is going to happen? So then the profit is going to go down. So it may happen that the firms start making some losses. So in that case, some of these firms will again start leaving in the long run. And then finally, what will happen? The price will be at the minimum of the average cost. So in the long run, the price of a good is always at the minimum of the average cost. And based on that price, we will know how many firms are going to operate in the market. Okay, so this was the perfectly competitive market. So in this perfectly competitive market, we know the information is complete. Every firm knows what is the cost function of its own cost function and the other's cost function. It knows the market demand and it knows the market price. Market demand, whether it knows or not, it doesn't matter because it can't decide the price. What it can decide is only its output. So it only knows market price, that is sufficient. Next, we move to monopoly, and that was done in week 4. And in monopoly, so in competitive market, we have many firms. In monopoly, we have only one firm. And this firm can decide the price or it can decide the output, and based on the market demand, we will get the monopoly price. So we have seen how a monopolist is going to decide its output or its price. Any one of these two, and the convention is to decide the quantity, that is output, and based on the demand, market demand curve, we will get the monopoly price. So here we get that the price, the monopoly output is such that marginal cost is always equal to marginal revenue. Okay, and price is always greater than the marginal revenue because we have a downward sloping demand curve. So in a monopoly, we see that the price is always going to be greater than the marginal cost. Whereas in the perfectly competitive market, we have seen that the price is always equal to the marginal cost. And how much price is going to be higher than the marginal cost, it depends on the elasticity of demand. So a monopolist will always produce that good which is elastic. We have derived that result in week 4. I think in the first lecture. Next, we have looked at price discrimination. So price discrimination is actually different strategies that a monopoly can follow depending on the available information it has. If it has only the market demand as the information, but it cannot identify the buyer separately, then it may have to do with second-degree price discrimination. If it knows that the markets are completely separated, market from consumer from market 1 cannot buy from market 2. So in that case, it can do third-degree price discrimination. But a monopolist, if it has all the information, if it can identify the buyer, it knows the demand curve of the buyer, then it can do first-degree price discrimination. So we have done one example for each of these cases. So this is the monopoly. So these are two benchmark model of market. One in which there are many firms and the firms cannot decide the price. It can only, instead it takes the market price as given. And the second, it is a monopoly where there is only one firm and it decides the market price. Next, in week 5 and week 6, we have done game theory, because to handle other forms of market, we will require a new tool, and that tool is the game theory, is provided by the game theory. So in game theory, we have only done complete information games, and we have done two forms. One is the static game, that is the normal form game, and another is the dynamic game or extensive game, which is played in stages. So in the static game, first solution concept. So in a game, what do we have? We have actions of each player, and each combination of action of each player is going to give us a payoff. If player 1 chooses a particular action and player 2 chooses a particular action, then it will lead to some payoff, that is the outcome. Or we write it in terms of utility, or when we will do the market, then we will write it in terms of profit. So this is the payoff function and these actions. In a normal form game, action set and the strategy sets are same. And first solution concept that we have studied is the iterated elimination of dominated strategies. Where what do? We first start by eliminating the dominated strategy. Dominated strategies means that a strategy whose each payoff is going to be less than the payoff provided by some another strategy to a player. So that's why it is dominated. So next, what happens? So we keep on deleting this or eliminating this dominated strategy, then we end up at only one outcome, and one outcome is one combination of action of each player. But that may not be true. We have also shown few examples in the lecture where we cannot come down to one particular action, combination of action. So we need a better solution concept, and that solution concept is a Nash equilibrium. And we have studied both pure strategy Nash equilibrium and mixed strategy Nash equilibrium. In pure strategy Nash equilibrium, what do? We fix the strategy or action of one player and then look at what is the best response of that player given that action of the player. And then we looked at whether suppose there are two players, player 1 and player 2, and suppose it is the prisoner's dilemma. So if player 1, suppose, is choosing his action, so it will choose in this way. Suppose player 2 plays cooperate. Then what is my best response? Whether to cooperate or not cooperate. So in the prisoner's dilemma, we know that it is better not to cooperate. Then when the player 2 is making a decision, it is deciding in this way. Suppose player 1 decides that it is going to choose not cooperate. Then what is my best response? If my best response is also not cooperate, then this non-cooperate is this pure strategy Nash equilibrium. Because when player 1 believes that player 2 is going to play not cooperate, then my best response is to play not cooperate. And when player 2 believes that belief of player 1 is to play not cooperate, then the best response is to play not cooperate. So we get this as one outcome, and this is a pure strategy Nash equilibrium. So it is actually the best response. So given the strategy of all other players, what is the strategy that makes my payoff maximum? And if I play that, whether the strategy that I have considered by choosing mine, then whether other players' optimal response is that or not. If it is that, then it is a maximum. So we have solved many examples of a normal form game where we have found pure strategy Nash equilibrium. But there are some problems like the matching pennies. So in that problem, we have found that we do not have any pure strategy Nash equilibrium. then what to do in that. So we introduced a probability over the action set or the strategy set. So each element in the action set or in the strategy set will be attached some probabilities, and then we will look in terms of the best response in terms of probabilities. So, and that will give us the mixed strategy mass equilibrium. So what we have done? So here, so when player 1 is attaching some probability, suppose each player has two strategies or two actions. And suppose take the case of matching player. So each player has, there are two players, each player has two actions. Okay. Now when player 1 is attaching probability to action 1 and action 2, then it will only attach probability when its payoff from action 1 and action 2 is same. If the payoff from action 1 is more than the payoff from action 2, then player 1 is going to play or choose action 1 with full certainty. So, how to find the probability? What is in this case? So, the probability that player 2 is going to attach to its actions, we find it based on whether player 1 is going to be indifferent among its strategies if player 2 plays that action. If player 2 plays based on that probability distribution. Similarly, player 2 is going to attach probability, some positive probability to action 1 and action 2 if and only if the payoff from action 1 is same as payoff from action 2. Because if the payoff from action 2 is more than the payoff from action 1, then player 2 should choose action 2 for certainty, full certainty. So that's why it should be indifferent. So we will get the probability that the player 1 is going to attach to the actions, to its actions, when so that the player 2 is indifferent between its actions. So using this criteria, we will be able to find the mixed strategy mass equilibrium, and we have solved few problems. We have solved them in tutorial also and within the class also. Next, we have moved to dynamic game, and in a dynamic game, what we have done, we actually the actions are taken sequentially. Player 1 moves first, or player 2 moves first, or they may suppose player 1 moves first, then player 2 moves, then again player 1 moves. So then it becomes a 3-stage game. So like that we have discussed few examples. Now here we solve the solution concept we use, mainly not the solution concept, the technique that we use, it is the backward induction. What do? We first move to the last subgame. And then we find the optimal strategy, optimal action in that game. Then we go on to move in above. So from the last part of the game tree, we go on moving. So if we suppose the game is something like two players are playing, player 1 moves first, player 2 moves second, then what we will do, we will go to each node that we get after player 1 has chosen an action. And then in that node, we will find what is the optimal action of player 2. And then we will write the payoff that the player 1 and 2 is getting if player 1 chooses that optimal action in that node. And then player 1 is going to compare among all the actions that it can choose, and based on that, we will get the backward induction outcome. Now here, the solution concept that we use is subgame perfect Nash equilibrium. So in the subgame perfect Nash equilibrium, it means that for each subgame, it should be a Nash. So what we do, so we go to the last subgame and we obtain the pure strategy mass equilibrium in that, or even we can find the mixed strategy mass equilibrium. Then we go to the next subgame and then we find the next mass equilibrium outcome, and then we go on like this and we finally get the outcome, and it is the subgame perfect. Now you will see that a mass equilibrium and a subgame perfect mass equilibrium, they are same, but but in a subgame perfect mass equilibrium we needed one more additional condition, and that condition is that there must be, if there is non-credible trait, then that is not a subgame perfect mass equilibrium. So we can eliminate some of the pure strategy mass equilibrium from the set of subgame perfect mass equilibrium by using this criteria, that whether all the actions are credible enough. If any action of any player is not credible, then it is not going to be part of a subgame perfect mass equilibrium set. Okay, so this is done. Now what we have done next is a mass dynamic game or an extensive game can be represented as a normal form. So what we have to do? We have to then specify the strategies. So the strategies mean the complete plan of action. That means what is the action player can take in each node or in each information set it is when it is there. So in a two-player game, if there are two actions and if player 1 moves first and player 2 moves second, then what do we see? That the strategy set of player 2 has 4 elements and strategy set of player it has 4 elements because it can have 4 strategies, right? Not in node 1 in first information set, then in second information set, like that. So we will have 4 strategies, and for player 1 it will only have 2 strategies because it is taking decision only in one node or in only one information set. So this is the strategies, and based on this we can represent the whole game as a normal form game, and from that we can find the mass equilibrium, and then we can compare whether this mass equilibrium is a subgame perfect mass equilibrium or why a pure strategy mass equilibrium is not a subgame perfect mass equilibrium, right? By using whether there is any credible trait or not credible trait, like that. Now here we have done 2 forms of this game. One where the information is perfect, that means that each information set has only one node, singleton. It's a singleton set. And another is the imperfect information game, where some of the information set of the players are not singleton. Means they have not observed the action taken by the player just before them in the game tree. So we have solved both this type of game till now. So this is mainly the overview till this point. Now, so I have also added a tutorial so that you can get some more examples how to solve the problems. And so if you have any query, then you can ask. Okay, if you, so I'm uh, leaving then because no question or no query from you. So I end this session here.